general overview of a multimeter and some minor basic electronics. So most multimeters are going to be the same, just more different functions. This here, you can see, is a Fluke 87.3. It's sort of my preference for meters. I use the same brand at work. So we'll get on to some of the general functions. So this can actually do AC, DC, resistance, and current. You can do general frequency measurements. I'm not going to do the capacitance or capacitor check. That's what this little blue one is. This meter's a little bit funny with that. So we'll start off, we'll work our way around. So start off with AC. The only way I can do this is measuring an outlet. Be very careful when doing this because it is extremely dangerous in high voltage. Well, high in an aspect for normal usage for what people would deal with. So plug it into an outlet. As you can see, my outlet's reading 122. So general US 110 to 125 is what you're normally going to see. Everything will still function correctly. So we'll remove those from the outlet. And we'll move on to the next, which is DC voltage. Now, I'm going to move this actually to millivolts first, then to regular voltage. So I'm going to turn on my power supply, and we're going to go to my inputs here, which we're reading about 384 millivolts. Now this will go up to about 900 millivolts, just about one, and then it's going to error out. Now I'll show you what an error looks like. It's basically a simple overload. See if I turn this up enough. Yep. So OL overload, which means I've gone way past the reading. But we click down to voltage, measure it again. Okay, I guess my meter is a little bit picky, so we're at 0.8 volts. We can actually go up to higher range. So there's 3. There's 9.9. So go off from there. So let's go to resistance next. Now, I'm not going to go too much into resistors in that, but we'll do color code for some people. So color code, it goes from 0 to 9. The color starts off at black, then brown, red, orange, yellow, green, blue, violet, gray, and white. Then you have 2 other colors, which is gold and silver. Those are tolerances. Those will be at the very end of the resistor. Now, I can show you a quick example here. This thing will focus. So, we have orange, white, brown, and a thin gold band. Now, so that means this should be 1, 2, 3, 4, 5, 6, 7, 8. So 390. So 390 at 10%. So if we, as a technician, the color code was pounded into my head, so it does take a second or two for me to get it right. So it's in. So it's at about 390. Come on. 383.5. So you figure 10% tolerance, we're still within that value. Now we have one down here. Bring this guy up here. Come on, focus. There we go. This has 2 reds, 2 blacks, and a brown. Now, so 2, 2, 0 with no more zeros. So 220, period. Now the black means 0.1 tolerance, because you start getting into different, now usually this blue coating will tell you 0.1%, so this is a high accuracy resistor. So if we put this back down and we measure across it, we'll get 220.1. So we're pretty close to, well, 0.1%. We're right on to the resistance. So leave that there. Now, next we'll move on to diodes. Now, this is diode check. Now, I have a few different diodes here, so I'll get these resistors out of the way for now. I have a large 30 amp resist diode. Okay. Have a smaller diode. I won't go into types because there's a lot of types. Most people know there's a regular diode, and then you have everyone's favorite LEDs, light emitting diodes. Even got a funny little square one here for you. So this one I can't really push in, so we'll just leave it here. Now, you have on a diode called an anode and a cathode. So we'll come up here. Now, all diodes, except LEDs, will have a little thin bar on one side. That is the cathode, or negative side. Now, most diodes are, to check if they're good, is we're going to go across it. Now, a good diode is supposed to be 0.7, but real world is usually 0.3 to 0.7. This is 0.6, so it's actually fairly good. So we'll set that one aside. Excuse me. We'll pop this little guy in. We'll go across him. And he reads 0.5, so he's good. Now, if you go, some people might go backwards. Well, it's not going to do anything. Now, one neat thing about most multimeters with a diode check and LEDs is there's just enough power to light the LED. Now, there's two ways, or a couple ways, to actually check which side is correct. Now, if you look, we have this flat end, short leg, and if you focus, a large flag. Those three tell you that's the cathode, so the negative side. Positive side's always the long, so you can go either way, long positive, short negative, or the flag. Now, let's see if I can, we have to put these across the side. Now, to check if it's good or not, it lights up 1.7 volts, so that actually also tells you how much the diode is going to use up. Now, different diodes usually use up different voltages. Red's your common, blue is sort of a less common one. This one's going to use 2.5 volts to light up nice and blue. Let me pull. Now these are 5 millimeter. Here's a little 3 millimeter. Oop, wrong way. That lights up just a little. That's still 1.7. So now this guy is red and really bright. He'll show up not as bright on the screen, but on the back side you can tell that these two here, focus, sorry, these two here are your negative, and this is your positive. So next, we'll set up real quick for current. Now, how that's done is you have to pass through. So we'll go to milliamps, pull out this probe, move it over to here. Now, what you have to do is, we've got our negative and positive coming from the supply that's off. We have to route it through one of them. So what we can do is we can hook the negative here. Take resistor. We'll take blue diode. What we're going to do is we're going to touch the other end of the meter to the blue diode side. Now I'm going to turn on the supply. Now if you watch, the LED should come on and you should read current, which should be a very minute amount. So you have here, lights on, and we have 5 milliamps. Fairly simple. Amperage, my supply can only go up to 1 amp, and I have to daisy chain more resistance to get just what I need, or even less resistance, which I don't have. So, fair enough. Nothing on. Now what we can do is we can swap over to the amperage, touch again, and that's 5 milliamps. No pointer or anything. So, we'll pull this out, shut the DMM off, turn the power supply off, and that's general use of a multimeter. Now, we could go into one more, which is continuity resistance. Now, normally, like I said, you can go from 1 or 2, or if you just wanted to see if 2 points were connected, set this one here. So here we go. So it's connected. You can also do this. What this does, it just has a sound, so if you're not able to see your meter, but it at least tells you that it's connected. So we'll end it at that. Sorry I swapped around at the end.